So in this question, right, there's 2 packs, isn't there, of metal rods with 4 rods in each pack, and in one pack the rods are of length 6 meters and the other pack they're of length 10 meters. Now they don't tell you sort of the dimensions here, but you just got to think about this logically. The only way this will work, okay, is that you have 6 meters for the square base, okay, and then the edges of the pyramid then are 10 meters. Okay, if you did it the other way round, if you had your base to be 10 meters by 10 meters, then if you think about it, these edges then, they would only be 6 meters and they wouldn't be able to meet up with each other because they wouldn't be long enough for the fact that you have a really big square base here of 10 meters. So you've got to do it this way, all right? And it says here, doesn't it, to calculate the acute angle between BD, okay, and the rod DP, okay? So they do help you a little bit here, don't they, with this, because they say between DB, the diagonal, so maybe we can draw that in, okay? Maybe do a dotted line, so it's a little bit less hectic in that diagram. But what I hope you can see then is we could actually work out the side BD first, couldn't we? You know, because we want to work out the angle, but let's work out the side first, okay, using Pythagoras, because you've got a right angle triangle, of course, okay? So you've got your A, B, and C there. There's your A, there's your B, and your C then will be that diagonal, which is the hypotenuse of that triangle when you look down on it. So we're going to have 6 squared plus 6 squared is what C squared is. So if you work that out on your calculator, that comes to 72. And then you just got to square root then, 72, okay? And that actually comes to 6 root 2. So we maybe write it down like that because it's quite nice, okay? It's exact. You can write it down like that there, and it's not a problem. Now, that's the length of the diagonal BD. But if we want the angle that's created here, let's say call it angle X, okay? What we need to do is to form a right angle triangle, okay? And you can see I've already sketched one in advance here, okay? And that right angle triangle I'm looking at here is the upright one you've got if I was to draw from the apex down towards the center of that pyramid, okay? So you've got an upright triangle there, just like in the last question, okay? And you've got from the apex to the center of the pyramid, and that's important that it is the center of the pyramid, which means then we know that side. If the whole diagonal is 6 root 2, half the diagonal is 3 root 2 there, yes? You just halve it. So I know that side is 3 root 2, and then you can go about then working out your angle X, okay? So right angle triangle, right, that being drawn down here, opposite the angle there, okay? Adjacent to the angle here, okay? And then of course your hypotenuse here, okay, the longest side opposite the right angle. Now I know H, don't I? And I know A. So with regards to SOHCAHTOA, TOA, it's going to be that middle one, isn't it? So A and H, so car, okay? So we're going to do it like that. So we'll have cos X equals to then, first one divided by the second, A over H, so 3 root 2 over H, which is 10. And then we can leave that like that, but to get X, then you've got to take the cos over, to cos to the minus 1. Okay, 3 root 2 over 10. So shift cos fraction 3 root 2 over 10, and then we press equals, and we have 64.9 degrees there rounded to 1 decimal place.